Hello, hey everyone. Thanks for joining again. My name is Shogun Adebayo, the creator of Check for UI and several libraries, I guess, out there. Really excited to jump on another stream again today to sort of continue on from where we left off the other day. So today we're on episode 2 of building a draggable panel using Stately Studio and XState. And I have with me here Farzad. Farzad, you want to say a word or two?
Sure, yeah. So it's great to be here again. Hello, everyone. My name is Farzad, and I work as a software engineer at Stately. I'm very glad to be here again. We're going to take things to the next level. We're going to build things practically a little bit more and take things out of the theoretical model level today.
Yeah, that would be amazing because I think we did a lot of like from this state to that state the other day, and it's like okay, today we are gonna like try to make it more like practical so you can see something. It was practical the other time, but then like developers love to see code. I think now is sort of the time we get to actually like get to see some code gymnastics, I would say. So yeah,
Yeah.
so let me give a quick recap of where we sort of like ended up the last episode. So I'm gonna add my screen to the stage. I kind of like walk you through. So the last time we looked at like the anatomy of this draggable panel. Of course, not the most pretty UI out there, but we've got like the trigger, which is a button that opens the panel. We've got the draggable panel itself, and then we've got like the drag handle, a close trigger, a resize handle, and if we've got some extra time, we could definitely look into like the ability to dock that panel to a specific section on screen. So when we did that, we moved over to sort of like model that using the Stately Studio, which is really amazing. Here's what the model looks like. You can watch the previous episode if you probably are not familiar with how we came up with this diagram here. But then this is like such a cool way to visualize the logic without actually writing any piece of code. All we did was draw boxes and arrows and actually think through it from like a top-down approach, thinking about how you build these components. So today we're going to take it away from here to actually like convert this to an actual working playground. Of course, I could go set up VS Code and like I mean try to do create Vite app and stuff like that, but just wait and see like some extra magic that comes in with this Daily Studio because I think we can generally take this and generate some sort of boilerplate code. So I'll pass this on to Fazad now so we can go for the next one.
Sure. Do you think maybe I can start presenting my screen? Um, Maybe that's going to be a little bit more helpful. Just try to figure out how to do this again.
Yeah,
Great.
yeah, sure. Yeah.
All right. Let me know, please, if you can see my screen.
Yes.
Great. Yeah. So as they said, like we built a pretty good model of how things should work in two different scenarios last time. We handled a very basic scenario of dragging, where things start from pressing to moving to stopping, and we dealt with how we kept things in the context of the state machine, like the diff of the movement across two different axes, X and Y, and how we keep track of the original position so we can backtrack to that if we want, or um, um, we could do more stuff with it, like as long as we keep that in the context of the machine and we remember that and things like that. You can again like go back and watch the episode for all of the details and see how we struggled to do that. um, Joking aside, I think this looks pretty good to take it to the next level, which is a practical level. As I said again, developers love to have things, dirty and working, and they
Yeah.
can interact with it. So they love to see some code. Now, what the Stately Studio does is after you have a good foundational model built with boxes and arrows, you can take that to the code level. And there's a code panel here, right on the top left section, where you can see the code generated for the model that you created in different formats. For now, it's going to be sufficient to just look at the TypeScript code. Now, the code will look like a state chart configuration that the XState library will need in the runtime. Um, So for now, I'm going to disable XState v5. V5 was released a couple of days ago after years of hard work.
Yeah.
But for now, we're going to stick to v4 because we don't want to feel like we're rusty with v5 on the live stream. um, yeah. Anyway, there are actually multiple ways of generating a template, a starting template from your model to an actual running application. For React lovers, there are three ways here. You can of course always copy the code over to any project that you have and store it the way you want, and then work with it in your project however you will.
Mm,
But for React lovers, there are different shortcuts. You can generate a React application, which will use the I think it's Sandpack from Code Sandbox team that will
yeah.
generate a very basic practical example of how it works based on the events and the context that it creates. But a better way of working with the template would be to generate it using to generate a foundational UI using Stackplates or Code Sandbox. Let's go to Code Sandbox. I'm going to open this, and it will probably error out because there's a generic UI and we need to remove that, and work out the UI to whatever we want.
Mm,
Um, as soon as this Code Sandbox frame loads, I'm going to invite you, Sage, so you can help me
yeah.
out with building the UI. It's
Yeah. Let's do
taking
it.
surprisingly long time to load. Now, folks, this is
Yeah.
Code Sandbox, not a studio. Okay, yeah, as I said, it's going to error out because there's some generic UI here, of course, but the state machine code has been copied over, formatted pretty nicely for us. And there's a main TypeScript file here that uses raw DOM API for interpreting the machine and
Mm,
trying to give you like a very bare bone basic dynamic UI based on the events and your state machine configuration. But we're going to get rid of all of this. Probably not all, but just, yeah. And I mean, we'll get to that. But it's installing XState v5. Yeah, we're gonna. I think if I just do something like, how do I reference the latest 4 here?
mm.
Dependency. Actually, I'm just gonna remove this. Fork this,
Yeah.
remove this, and XState
We're
at
gonna extend.
4.
Yeah.
I think that's
That's
gonna,
four.
yeah.
Yeah. Correct.
What is? What sandbox? Oh, it's not. Wait, what? No, this this can't be possible. I think it was
Yeah, we can do like
4.8 if
yeah.
I remember the latest one. Yeah, I think that's okay. And
Yeah, we could
then
also do like a 4.x, like whatever like x means. I mean, work it
oh,
out.
that's gonna
I
work.
guess. Yeah.
Great. This is a great way of working with library maintainers. They know all the things around dependencies. So let's do XState React as well. I think we need to stick to version 3 because that works with XState v4. Maybe let's
Okay.
just do that to be sure. Amazing. So yeah, the little UI that we saw when we were generating in the Stately Studio here in Generate
Yeah.
React App, it's generated again for us in Code Sandbox. And
Nice.
the beauty of state machines is like, just take a detour to just show me my hype around this here. The beauty of a state machines is the UI, the generic UI doesn't have to know the events that are available in your state machine up front, because it can query the events that are available at each step, at each state, basically in the state machine from
Mm,
XState. XState will give you, hey, I mean, state 1, and here are like these available events to take to go to, potentially to transition to other states. It's like
mm,
you're on a map.
nice.
Imagine you're on a map on a street, and it tells you, hey, like Google Maps says there are 3 different ways to go to the next street. Which one do you want to take?
Yeah.
Sort of like that. Maps out the whole blueprint of what you can do. So yeah, that's beautiful. But let me figure out how to add you here as somebody who can edit. As I
And then you can
have
do
no
like
idea how to do
share,
this.
I guess. Yeah, this share at the top right.
Right,
Yeah.
right. Wow, this is confusing.
Yeah,
Okay,
so you can
so
copy the link. I'll just send it over to me, I
yeah,
think.
yeah,
Yeah.
this can work. There you go. And
All right.
we'll see you when you're here.
Yes, correct.
Yeah. So as I said, we can get rid of all this UI, and Yeah, interpret is deprecated because there's create actor now, but I mean, we're going to stick to the old syntax for now.
Interpret, yeah.
Um, yeah. So again, the Figma link from the previous session and the one that say showed you in the beginning of this very live stream demonstrates a very basic stroke-ish element here that we want to build. So we basically want to have a bunch of divs in the DOM and like 10 pixel wide uh, borders around them, very, very strong borders, and
Yeah.
just demonstrate how things work when they're connected to the state machine that we created from the previous session. So Serge, do you want to handle, I mean, like, just let me know when if you can hop into the code sandbox
Yeah, I
screen
think
here.
for some reason, so what you can do is click the share button, and then you can maybe add me by my username,
Sure,
which is I'll send it
just
to you over here in the private chat.
no longer private.
Yeah, of course.
Wow. This is the first one, right? I suppose.
It's probably taking a long time. So yeah, that's it.
And edit as well. Edit away.
All right, I'm just gonna reload this one.
Yeah,
Just
it's
wait
got
a little.
pretty, but a little weird because sandbox used to look differently before.
Yeah, it's a
Um,
little bit laggy on my end as well. I'm just waiting to see a notification. Okay, I see it now.
yeah,
All right. Can you see me here?
yeah. Maybe I need to create another sandbox because when we use opening code sandbox, it creates a how to say, like, it doesn't create a React application. It actually creates a raw JavaScript application. It's a native
Oh,
JS
I see.
application now. Yeah, we don't want to really deal with DOM queries right now, right? So let me just
Yeah,
tell
yeah,
you
yeah, correct.
if I can. Oh, we don't have to actually do that. Let me create a React application again. Open sandbox here. There we go. Great. Yes, it's a React application with the same structure. Amazing.
Nice.
And I'm gonna, yes, invite you again and allow you to edit my sandbox.
Mm-hmm.
Yeah, I think we're pretty set up now. Just let me know when you're in and we can start editing. So
All
I have
right,
my
let's
machine
go then.
file again, and there's an app.tsx for the main component that's been generated. It's basically the same idea with the generic UI that we just saw in the other sandbox, but this is just JSX and conditional rendering now. So while Sage is loading in, I can give you a little tour of how this thing works. So we will use XState as the main library because XState is what we need for the runtime for now from the code that the Stately Studio exports. XState is the library that implements the idea of the state machines and the state charts in the JavaScript and TypeScript world. Um, and it has integrated, it's framework agnostic. So you have to add the packages, proper packages to integrate it into your framework. If you were using native JavaScript, you wouldn't need any frameworks. But if you're using React, you want to use XState React, Vue to its corresponding XState Vue, Svelte, Solid. There are different integrations that you can check the documentation. The React integration one gives you a use machine hook. So we saved our state machine in a separate file. We're importing it here. We'll call use machine inside our component, pass the machine configuration, the JSON configuration,
Mm-hmm.
to the hook, and it will give you a tuple like use state. The first one will be the current state of the state machine that's running in your
Mm-hmm.
component now. And the second one would be a send function. And this send function is like, if you're coming from the world of Redux, you
Yeah.
know this as dispatch. Or if you've used, use reducer in React before, this is again the dispatch one. So it's basically mirroring use reducer, where you get the current state and a function to dispatch events.
Got it.
Working with
So I have
reducers in Redux, people call it actions, but they're actually events. Go ahead.
yeah, correct. So I've got like one question from Gordon. He asked like, why do I need a state machine for building components? Like, why can't I just go ahead to just like write it the way I'm used to? Like, what's the big deal about this state machine thing?
Well, there is absolutely no need to write, the logic of your components in state machines. I usually lean towards state machines when I feel like there is enough complexity that I'm dealing with. So I know state machines have a million benefits, including visualizing the logic that I'm building, trying to find dead ends and impossible transitions and state in the logic. I will see, the breadth and the depth of the problem I'm solving at once by looking at the diagram that it gives me. There are a lot of more benefits out there by just using state machines, but there's no need to do that. Actually, you can stick to any solution that works for you. We're just advocating here that the state machines are a good way to tackle complexity. But if you don't feel like there is enough complexity to bring in a tank, well, of course, you don't want to, you don't want to go shopping in a tank. Uh,
Yeah.
you can use the right tool for the right problem.
Yeah, that sounds good. I think like one interesting ideology I learned recently is like you don't want to put rocket fuel in a car. That's because the car is gonna explode, pretty much, right? So state machines are like pretty much that beast. They can help you like tame the complexity. So if you're building out a highly like richly interactive components that might have a bunch of edge cases that you want to handle, that's one. And also, if you're building, logic in so if you're interested in building the logic in such a way that is framework agnostic, that is not tied to like React or tied to Vue or tied to Svelte, it's pretty much JavaScript that can be used anywhere. So the idea, one of the things I love about state machines is you model the logic of a component once, and you get to use them for free, like in any framework of choice, which is the real benefit for me. And of course, the visualization and the simulation part. I think these are the key things that I'm really sold on when it comes to state machines.
Yeah,
All right,
that's
so
absolutely correct. So one little story while we're at it. We are so Sage here is the creator of a library called ArcUI. And Arc is built on top of Zag, which is a set of state machine models for different UI components. So okay, I'm sorry that I'm telling your story, but it's sort of like I'm
please go ahead.
narrating your story. So you built, like, the way I see it is that you built Chakra and you learned a ton about building interactive, accessible UI components by building Chakra UI, and then you realize there's a lot of complexity to be tackled. So you went on and created Zag.js, right?
Yeah,
To have a framework agnostic way of modeling the complexities of these components. And then you built ArcUI to give out a component API, an intuitive API on top of the state machine that drives the logic of the component. So, fun fact, we're using ArcUI, one of the ArcUI components in Studio to build out a new feature. And I was literally using it last night. And I even asked Sage about a certain API of the component last night. But our very own Nick, our product designer in Stately, he, before we figure out the solution, he looked at the state machine visualization of that component that is open source in ArcUI,
yeah.
and he figured out that in like 2 minutes.
Oh wow.
So he figured out where the logic is, and he found out, well, actually, we can work around this problem like this because the state machine is showing me that the behavior is, working this way. So in this scenario, we can actually do this and it's safe. So
Nice.
that was pretty mind blowing.
Yeah, that is so cool to see. I wish I was part of that story. Sort of like see what's actually going on, but I'm actually really, really pleased to hear that story. It's awesome.
Yeah. Maybe we can do a live stream on that at some point. Anyway, circling back to our problem here. So we do have a state machine that's running using some nifty hooks. All is great. The state machine state object will give you a lot of things. Like if you console log the state here, we'll see not only where is the console. Wow, these things has changed. To use terminals, you need to convert the sandbox to devbox. I have no idea what that means, but oh wow. So I don't get the. Oh, okay, maybe the console is here. Yeah, that's the other console. Yeah. So the state machine object is like a huge object that contains different information. Um, the value of the state that we're in, like open, panel, closed, these are the names of the states: idle, pre-dragging. Those are stored in a state.value. So we know that we are in the closed state right now, and if I click on open panel, it's going to send an event to the state machine, and we're transitioning to open and immediately to idle state because there's a child state. And the value of the state that is contained inside this object is changed to an object that says I'm in open and starting from the idle state. So there are two levels now. And how magically these buttons are shown are basically based on the next events that the state object gives you. Now the API has changed, but in V4 it used to be next events. Um, I have no idea why we don't get the TypeScript interface here. The inference, we should have gotten everything. I don't know how Code Sandbox is working.
Yeah, I think do we have like do we have the React types installed? Because I think
Oh,
like sometimes you have to like manually install the React types.
yes, really? That sounds dumb.
I'm not
But
sure if
like
that fixes it,
the
but I think
types
like
should have come.
from XState.
Yeah, it feels like I don't even get, I didn't. Let me just reload. Maybe it needs to reload the TypeScript language service.
There's a very good chance this has to do with Code Sandbox. If it's a bit of an inconvenience, we can switch to stack plates, I think. Yeah.
Yeah, for the phone. Yeah, well, we do have the generate React app. If we were to do this for React, like stack plates, we would have to set up the stack plates ourselves. But for now, it's fine. State.next events. So what I'm wondering about is why I don't see the next events here, because yeah, we can head over to docs actually and try to look out state.next events. Yeah, so what? Yeah, I do have XState v4 installed. Why is the XState at beta?
Beta,
So
I
that's
see.
the thing. Yeah, that was the problem. And XState React, where are you?
Yeah, just above. Yeah.
Yeah, that shouldn't be beta as well. That should be 3x. There we
Okay.
go.
Much
Now
better.
things work. All right. Now I see that stated. So let's just call this next events. So XState will give you the array of available next events. So it tells you if you're in the closed state, based on the, if I'm at the closed state, the only way to get out of this and transition to another state is the open panel event that you gave me in your model. So XState knows the graph of these dependencies between the states and events, and it tells you that the next event right now, based on your state, is open panel. I click on this button. It actually sends that event to the state machine, changes the state, and now next events are changed, because when you're at open idle, you can even receive pointer down, close the panel, or pointer leave. And that closely mirrors how things work here. So if you're in the idle state, you
Awesome.
could get pointer down and pointer leave, and there was a closed panel as well, because that's a global event that we're receiving. It's somewhere around here. Yeah, so it basically mirrors the diagram that you created. And there's also a matches utility where you can pass in a key for the value of the state that you're in, and it tells you if you're matching that state right now. So let me just quickly remove this, refresh this. It says true because I'm in the closed state. Basically, I'm telling it, hey, tell me if my current state matches closed state. And the moment that I transition out, it says false. So that's an easy way of rendering something conditionally based on the state that you're in right now.
Yeah,
There are a bunch
I've got a pretty rookie question as well. Like, why do I have to use these matches when I can just like use a boolean, like use state open, true or false? Like, why do I need this complex this complex state dot matches function when I can just use state with a boolean?
So this state that matches tells you if the key that you're passing matches part of the state that you're in, because state machines are not always flat. It's not like I'm always in closed, idle, open state. As we can see here, sometimes part of the state machine is a child state of another one. So when you're in open state, you tell it to start from idle and have something happen as a subsequent child of the open state. basically this logic only happens when I'm already in open state. And if you're there, the state value in this object is going to be an object. And there's no easy way for you to say a state value is this object, because this doesn't work. So you can't really say I'm in open idle, something like that. That's why state like XState runtime provides you know this utility over that to partially match if you're in the current state or not.
Awesome.
But I feel like, did I answer your question, or were your answer like how you can? Were your question how you can use?
No, I mean,
How,
I think, yeah, I think that partially answers the question. I was just thinking through, like, I mean, this whole idea of state machines, and like, do I need a whole state machine just to close and open, like a panel, when I can just use the state? I guess.
depends. So in terms of using booleans, every boolean value is designed to represent two states: 0, 1, open, close,
Sure.
whatever you want to call it. And the moment you have your state permutations steps out of being 2 and becomes 3, 4, then in that's in that way the boolean is no longer an accurate way of representing the logic. Then you end up adding another boolean, but now 2 booleans have 4 permutations instead of 3, where you actually wanted 3. So you create one impossible state on your way. So you're adding more and more complexity just because the way that you're modeling it using booleans doesn't exactly match the amount of permutations your logic needs to have. If that only makes sense.
Yeah, that makes sense.
Yeah.
Cool.
Yeah, and then it's using the send function to send events. Not too magical. Basically sending events and waiting for the state to render something. So
Awesome.
I think at this step, we need to build out this.
Yeah, we need to build out the panel. Yep.
Yeah. Do you want to help me out with that, or how do you want to do this together?
Yeah, so I tried Code Sandbox, and for some reason I'm there, but you can't see me. So I think the sync thing is like not working at all.
All right. So
I'm
can
just
you
gonna
edit
put like
something, or
can I do like a log? Can you see my log there? I'm currently in the app TSX file, line 8.
Line 8? Not really. I don't see
Yeah.
your.
Yeah, so I think they've got a problem with synchronization. So
yeah.
We can trust this. So I guess maybe we can build it live together. I can.
Yeah. I mean, not a big deal. I'm just gonna put a bunch of divs here.
Yeah.
Yeah. So, just completely remove this and let's create a div here. Honestly, Chakra UR makes it so convenient for me these days to work out in different projects that I wanted to just, bring in Chakra and use Box. Anyway,
I think we need a button here. So most likely just like a button to trigger the things.
I'm gonna be the devil and just use divs. Okay, I'm gonna. Yeah, this is not how I work every day, but I hope my boss doesn't say this. So I'm gonna call this. We can call this. What do we want to call this? Like,
what is that div? I think that's the question. Yeah.
Let's like that. This one is representing the whole component. This will be the header, and this will be the content. Something like this, like very traditional. And then we want a drag handle on the left side of the content. So, God bless the times that you could do front-end development using Emmet. I don't know if it actually works, but let's see. What was that? Drag handle. Oh, it actually works. Oh, hallelujah. So we're gonna call it drag handle, and this was panel title, and we're gonna put like a title here. Let's just put some paragraph. This is terrible semantic. But let's also use a button here and put like a fancy X in there. So this is going to be the close button. Then we need the content and another drag handle here. Or maybe we're going to call that resize.
And that's a resize handle. Yeah, correct.
Yeah. Okay, so let's work out.
I think we missed one more part, which is like the button to actually open the panel.
Oh, right, the trigger.
Yeah, the trigger out there.
Yep. So for that,
We need another
I'm
div.
going to use a
Yeah.
portal,
Yeah.
not a portal, fragment. Getting brain foggy here. And use a button here. Why not? Let's call this whatever it's panel trigger.
Yeah.
All right. Do I have a JSX issue here? I don't see one, but
No, you don't.
yeah, I think I'm fine. I don't know why I get these. I don't know.
Yeah,
Oh
it's
yeah,
fine.
okay, it's working
Yeah.
now. Great, 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 great. So let's jump into styles of CSS. Um, yeah.
I think we
So
missed one thing before we start the styles. So the
sure.
div in line 12, I think that div in line 12 needs a class name since that technically represents
Yeah.
the panel. Yeah.
Yes, that's absolutely correct. That's
Yeah.
there. Yeah. So we basically want this to tell us, right? Like 5 pixels solid. Yep.
Yeah. Nice.
See, design. Um, yes, that's absolutely correct. And then let's just go and what was the other one? Panel trigger. Oh, I want this fancy button and everything. Let's call this panel
Panel
trigger.
trigger.
Yep.
Oh boy.
Yeah. It's terrible. So we want panel header. I don't even follow a convention here. Yeah, let's just call it header. So we want the border again. Maybe we just want a border bottom here. Great. So
Yeah.
this is going to be a flex container.
Tell me
And
the
what
last
is it?
time you wrote CSS like this.
I don't even remember. Really. But this, we don't have CSS nesting yet. Do we? Last time I wrote CSS by hand, I suppose it was the era of CSS modules.
Yeah.
Few couple of
Yes.
years. Yeah, but I absolutely adore the old days of writing SAS. It was amazing.
Yeah.
SAS and CSS.
Yeah.
Yeah.
SAS is an OG.
Margin left auto, so push this to the right, and then we want a drag handle. So let's give it like 5 4M and give it a height of 4M as well. Background color green. Yes. Yeah, that should work. Then what else do we have?
Yeah.
Resize handle,
Maybe
and
resize handle.
the panel needs to have, let's give it some height. I don't know, 500 pixel. That doesn't overflow. It does. Let's give it 300 just for demonstration, and let's give it a width of max width of, I don't know, 200 pixel or something. That's too narrow. 400, much better. Yeah, and then this was flex align dash items can be centered, so we don't actually stretch everything. Much better.
And
So we
maybe a
have
little bit of padding, I guess.
Sure. Let's make it 1 rem. Yeah. Let's also give it a gap. So should be enough.
Yeah, I like it.
So there's a resize handle now that's going to be red. And
yeah, I think the class name is wrong. I think you got resize handler.
Handler. Yeah, absolutely great. That's
yeah,
yeah. We want to push it to the
bottom right.
Position is going to be absolute. Yeah, exactly. So it's going to be bottom 0, right 0. This panel content needs to be. I mean, yeah, the panel itself can have a position relative. Yeah, that should work. Very nice. Yeah, and we want the panel trigger I mean, it can be there. It's fine. Yeah. So what else?
Yeah, I think that pretty much makes it complete. Yep.
Yeah, great stuff. So what is the very first functionality we want to bake into it?
Yeah, so the first thing we'll do is if you go to the styles.css, let's move out the position relative to the content because the panel itself will be absolutely positioned. All right,
That's
most
absolutely
likely.
correct. That's absolutely correct. So let's give it content. Oh, but where's
Yeah,
the
I
content
think
up there?
the resize handle lives where does it live inside the content?
It does.
All right,
Where's the
yeah, and
content?
then we probably need some flex magic now. Yeah, because it's probably not that tall. Yeah,
Yeah, it's not tall at all. So I'm
yeah,
gonna give it flex one.
yeah,
That
and
should have
then the
question.
the panel needs to be display flex direction
Oh,
column. Yeah,
that's true.
CSS is so weird sometimes.
Sometimes, all the time. It's okay. 25? Yeah, of course. Yeah,
Yeah,
great stuff. So we don't really need the yellow background. We can get
yeah,
rid of that. Um, does it look fancy enough?
yeah. I think
It does
so.
look fancy
Well,
enough for me.
besides the button with the big border around it, I think that's fine.
Okay, you know what? I'm going to. There is another one here. Panel trigger. We don't have that. Header button. Where am I giving the panel trigger here? Yeah. So I'm just going to give it some margin for
Nice.
sanity for now.
Yeah,
Yeah. Yeah. Let's just
yeah.
assume that
So
we don't move it too much around. Okay.
awesome.
Great. So based on the logic that we created in the model, we first want to handle closed and open state. Sounds good.
Yeah, let's do it.
Yeah. So do we want to do inline styles? Maybe that's easier than
Yeah, yeah.
different
Inline
platforms.
styles, fine. Yeah.
Yeah. Okay. So I'm gonna give it a style, the whole panel, and I'll say if. So we're gonna tweak the display. So if state matches closed, this is gonna be none. Otherwise, this is gonna be flex. I hate it that I have to determine that it's flex or block here without me.
I think we can actually like improve that a little bit, which is kind of like use the hidden attribute. So we don't have to actually
Very
do
much better.
that.
Thank you.
So the hidden would be a
So this
property directly on the div.
true. Yeah.
Yeah,
Oh yeah, you're right.
yeah. So it just be hidden when state matches. Yeah, this much better.
Exactly. Much cleaner.
Yeah.
So when the state match, why are we not in statement value? Where are we now? We are in closed. State match has closed.
I
Oh,
think
actually,
it's the
state
reverse.
doesn't match. It should be open. Actually, yeah.
Open. Yeah, correct.
Great.
And then of
No,
course
no, no, no,
CSS.
no, 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 no. That was correct. It should be. It should be
No, no. I
hidden.
think we're fighting with CSS here.
But this is correct, right?
Yeah,
This
this
is
is
correct.
correct.
Yeah,
This is
yeah,
correct. Yeah.
yeah.
So if you head over to the CSS, because of the display flex we have in line 5, it's a little bit tricky. So what you want to do is write maybe another selector just below that sort of catches for when the panel has the hidden attribute. Yeah, and then set it explicitly to display none.
Wow, I thought that the platform will actually there's some user agent styles that overrides this. Huh.
Yeah, but I think that the user's style sheet has more precedence over like the
That's absolutely
browser.
correct. Yeah,
Yeah,
yeah, yeah. You're right.
yeah.
Thank you for being here, Sage.
You
So
know.
the hidden attribute of this is true now, and that's why the display is set to none. It's great. So if I click on the button, I should be able to open it, but we haven't handled that part yet. So that's where we need to add an on-click to this button, and we need to send an event. And what event we need to send? The same one that's here, open panel.
Open panel.
So every event again, if you're familiar with reducers or Redux, every by convention, every event has a consistent property to distinguish between different events, and that's a type property. So we're going to call it open panel. So the moment I click on this, it's going to send open panel, and that's going to, the state is going to transition to the open state. The hidden value is going to be false, and therefore it's going to show the panel in the DOM here.
Nice.
But like, I mean, I could actually just make it just this is toggle or something, so it's easier, so it would hide and show. But we don't want to do that yet. Instead, we want to close the panel when you click on the X button here. So let's take that out and add it to the X button here. What is the event that closes this? So it's a nice way of listing all the events on the machine without having to scroll through the whole diagram is to look at the event schema.
Nice.
This is all the present events in your state machine, and I can take a look at the close panel. And even you can even send payloads with the event, of course, and it shows me the schema of the event. And there is no entry, which means there are no properties right now. So it's just sending close panel. So I'll send close panel, and this will close the panel.
Awesome.
Very primitive, but it works. So far, we managed to bring a tank and model a single Boolean value. Open, open and close, true and false. But from here on, we'll see how having a state machine will, make it much, much simpler and easier to tackle just out-of-the-box complexity that we will encounter along the way. What else do we want to build? So if the panel is open, what else, what other features do we have in the model that we want to add to the DOM here?
Yeah, I think like the most basic one we can start with is just the dragging, sort of like the pointer
And
down.
that's going to be this one. Yeah.
Yeah.
So to recap how dragging works, let me just close this panel. If the panel is open, we are in the idle state, and we need to send a pointer down to get to pre-dragging, and that's where we save the original position. Then we need to send pointer move, and we need either a pointer cancel or pointer leave or pointer up to get out of this logic, to basically go to idle again. All right, let's do that. So we want this green box here to manage dragging round. Yeah. So I'm just thinking where exactly the DOM events need to live. I mean, of course, one approach would be to add the DOM events to the state machine itself, listening to the DOM events. Yeah, to the state machine itself. We haven't yet talked about invoked actors, but we can talk about that like later. For now, let's keep that in use effects here. And then maybe we can take another session briefly to refactor that to using actors at some point.
Awesome. Yeah, that's great.
Yeah, so I think for starters, we need a ref to the drag handle to be able to work with the underlying DOM element. So we're going to model is an HTML div element. What did I add that broke it?
I think you have a syntax error in null. The use ref.
Isn't this TypeScript? Oh yeah, of course. Yeah, it's because of this.
Yeah, correct.
Great, and then use ref, of course, it doesn't automatically import that. Great.
Awesome.
So we need a use effect. You see the whole TypeScript inference is broken.
Yeah, it's kind of broken with Sandbox for some reason.
Yeah. Okay, so we need the use effect with empty dependencies because we're going to add event listeners only once when the component mounts for the first time. So we can call it a drag handler or something. So we want it to be a single function so we can clear it up later.
Yeah.
And we want to add it to the underlying element on the drag handle. So we need to query current from the ref and add event listener. Such a pain to work without.
Yeah, pointer
or
down.
Maybe actually, you know what? It might be easier to just use attached pointer, like the attached handlers here.
Yeah,
Okay,
we could do that
on
on pointer down.
pointer
Yeah.
down. Yeah, why? It's easier. Great. So we have the event that we get from DOM, and all we need to do is to send pointer down. So I suppose we don't really need
Yeah, we have a
any.
guard there that says if it's coming from
Yeah,
the drag handle. So
of course, yeah, because we wanted to separate the two scenarios of dragging and resizing because both of them
reset.
start from pointer down. Yeah. So we need to. If you go to the state machine, there is a cond here. There's a condition basically.
Guard. Yeah.
Guard. Yeah, coming from drag handle that is passing the implementation as false. But we need to know that when we are, we basically need to know what we need to sort of provide that implementation based
Mm.
on the JSX that we have available here. That's why we need to take out these. Or actually, this can even live here. We can override it with the use machine hook and pass in implementations as specific that we want.
Mm.
So what happens here is you can override the implementation, the default implementations, or the missing implementations that are referenced inside the state machine configuration. I can have the guards and pass them here, and I can have the same name coming from drag handle. I'm going to provide this implementation specifically here because sometimes your logic is generic, it's general purpose. And
Yeah.
the way that you want to pass in implementation depends on where you're using this state machine logic. That's why you can override them at the consumer side.
Nice.
Yeah, so I can just say true for now. It's easier because we know that we're only handling that. Yeah, so let's see what state we're in right now. And another easy way of looking at the state would be to just with a paragraph here and show state.value. And because this can be an object, just stringify this for now.
Yeah.
Great, so we know that we're in closed state, we're now in open idle, and the moment I pointer down on this, this should have sent pointer down, maybe pointer down is this, yeah. There we go. All right, yeah. So we need to send the X and Y, and those are client X and client Y from the DOM. So we basically need to send e.client X, but that's something we need in the state machine. We said that we need these information from DOM.
Yeah. Yeah.
Oh no, wait, maybe pre-dragging. I'm assigning this from the event.
Yeah.
Event is
Yeah.
coming
So this
back.
one is directly from the actions, right? So the error that we're seeing right now is coming from
Yeah,
the
yeah,
action.
it comes from the
Entry
the
answer.
assignment action as an entry on pre-dragging, because the moment we send pointer down and this guard says I'm returning true, it goes to pre-dragging. But the thing is, this event is going to come. Oh, I actually forgot to add a flag here. Yes, so we need two flags for this to work. I don't do any
Let's go
friends.
preserve action order or something like this.
Yeah, exactly. Preserve action order. And there's another one. It's really funny. Preserve action
order. Yeah.
No, not this one. Predictable action arguments.
I see.
Yeah.
So why do we need these flags?
I'll get to that. Let me just preserve action order and let's make sure that we have the right. Okay, so these two flags, because originally how XState worked in previous versions and starting from version 4 in the beginning ones, like there are two flags here basically. One of them, preserve action order. When you set it to true, if you have multiple actions in your state machine configuration, sometimes these actions could be built-in action creators, like assignment, like the one that we have here. Assignment that returns an action for XState to execute to update the context value. The way that XState interpreter works is it keeps a queue of like a sort of an event loop under the hood to determine what's the next action to be executed right now. And it has two different queues. One of them is called the internal priority queue, and another one is the queue to process the external events that it receives. Long story short, it used to prioritize assign action creators over other actions that it received. So if you had action 1 assign action 2, intuitively you might have expected that they will run sequentially and synchronously. But what happened internally was it prioritized assign, and then when it got to the first action, the assignment had already been taken. Yeah, so you can set preserve action order to true, so that it keeps the action order execution, so they're predictable. And predictable action arguments means, again, originally it didn't send the events that you received here to the entry actions, but with this flag set to true, it will carry those events over to the entry actions. Yeah, but good thing is you don't need these two if you're using the latest version 5 of XState, because these two are deprecated and they're now built in. They're part of the built-in behavior.
Awesome.
Great. So one thing I want to understand is, so because this had X and Y and they needed to be carried down by the event that takes this in, but we still get that. I'm just
I mean, I think that like the fact that like context and event is destructured out, I think that is a V5. Is that a V5 theme, or is that like
which one are you talking about? This one here?
Yeah, so if you see the error stack on the right, line 38, the fact that we're destructuring out context and
that's
event,
absolutely correct.
That's like a newer
yes.
syntax, I think, yeah.
That's absolutely correct. Thank you. Yes, this is the syntax of the arguments that actions take in version 5, whereas in version 4, there were two different arguments here.
Two different arguments, yeah.
Yes, thank you very much. Yeah, I might have accidentally exported the code when I had the switch of V5 on, but I'm using V4 here. Okay, yeah, that's absolutely great. And cannot read properties of undefined reading X action. We do have the sign here, and we do have the event here. So I'm wondering, so I'm sending these in, and this event is also okay. The easy way would be turn this into an array and start logging what we receive.
Yeah, logging is always the best way to debug things.
There are more, fancy ways of debugging how state machine works, with XState. It's called the inspection. You can inspect a running state machine, but I mean, well, maybe we can get to that later. Okay, so remove these. I'm going to remove these warnings so we don't see them at all.
Yeah.
So it doesn't even show me those. Yeah, it's great. Is there a sort of, save issue or something here? I don't think it's even receiving these changes.
Yeah, it's not.
Yeah.
Oh, yeah, it works now. You have to refresh.
Yeah, exactly. Wow. I was like going insane for a moment. Yeah, so it updates to pre-dragging, and we now, get the X and Y properties from the done that we're sending along with the pointer down, and we receive it in the state machine in these actions. Great. So what we need to do again is to continue with this scenario. I'm going to finish this at least for a few minutes. Let's get this to a stepping point that we can, step out and continue in the next session, because it took us a long time today. So we saved the original position, and we know that by looking at the context that we have here, or another way would be to save the context here, state.context, the value of the context. And I'm going to remove this log, remove everything. Just refresh everything. So I have a diff, original position, and all that. And the moment I click on drag handle, original position is saved to the context. So I know that this was the original position on the screen that I started dragging. Amazing. So now that we're in pre-dragging, we need to send pointer move the moment you start moving your cursor around. And we can do that by adding a pointer move. And what pointer move expects from us is, again, X and Y properties from the event. So we need to send pointer move with X, which is e dot client X, and Y, which is e dot client Y. And this is going to be saved in the diff property in the context. There you go.
Nice.
Updating. Yes, so there is a problem here, and that is because we're attaching pointer move to this element, the moment your mouse gets out of the element, the pointer move stops being sent to the state machine, and that's going to be solved because we need to actually update the position of this drag handle around while we're dragging this. So the idea is this needs to be locked in, right? We need to lock it and then move the whole panel around. So this panel, we probably need to, as I said, make it position absolute and then tweak the top and left properties.
Yeah.
Yeah. So we have the original position and we have the diff. We don't care about the original position right now, but we can, just use the diff property and quickly tweak the top and left properties of this panel component. So one thing I'm wondering here is that we saved the original position
and pointer down, and we should send it diff, right? And pointer move, right?
Yeah, but like we are getting the position, the original position of the of where we point inside that green box.
Oh yeah,
right?
see. So
and
we
that's
need
not
to
necessarily
subtract
the original position. Yeah, we sort of need to. There was a way to, find the top left corner of the parent.
Yeah, we need to pass a ref to the panel and sort of subtract the left side of the panel from the client X. So I think there's just subtraction that needs to happen. So we can start by maybe adding a ref to the panel. If you scroll a little bit up.
Yeah. Okay.
Oh, yeah, so this one. Yeah, panel ref. Correct.
Yeah, let's just use this panel ref. And then
I think you have a typo in panel ref. Yeah, you just start like with a small letter.
There we
go.
That
one. Yeah. All right. So I think like in line 43, when we send the pointer down, we should actually like subtract out. Let's grab the get bounding client rect of the panel.
So we want the panel rect.
Panel ref.current, and then we can grab the get bounding client rect.
Client rect, and
yeah, so we have the X from that, I think, or left here. Yeah.
Yeah, for sanity check, let's make sure that we get that. So it's a DOM rect. There's an X and Y. Yes, you're right. So X is going to be the left properties to the left of the window screen for the panel. So that's going to be here. Yeah, but if my original position is here, then I also want the.
Yeah, I mean, so I think. Yeah, so I think I can crack this one at least. So we could do like line 49. I think we should not set like either client X and either client Y. We should actually send the panel rects X and Y position, because that's technically the original position.
You're actually absolutely correct. You're absolutely correct. So yeah, panel rect.x and panel rect.y.
And then on pointer move, we want to actually do the subtraction. That's where we probably want to subtract the wherever the so let's grab the panel rect now.
No. What we don't really need to do that, right? Because everything is supposed to move at once. So the diff of this element is the diff of the panel as well. Everything moves at once. So the X is the same for everything that's inside panel.
Oh, I see. All right, let's try to see.
I think this should work. So this top property is going to be state dot context dot. So what we have is the top property. There is an original position.
Yeah.
Oh my god, it's like barbarian times.
Original
What's that?
pose.
Original pose dot y plus state dot context dot diff
Diff.
dot y.
One.
But there
Correct.
is no y here, so it's a top. So it's going to be one.
Yeah.
And we basically want the same thing for the left property, where we
Yeah.
get the first item. Oh wow.
Yeah.
Well, not too bad. Not too bad. Not too bad. It's moving. It's moving. Now I know what exactly is wrong here. So it, the moment
Probably don't
my
want to apply. Yeah. Let's see.
yeah, we need to lock the pointer to this element, so it doesn't matter where we, like, if your mouse gets out of the frame of the panel while you're dragging around, you no longer send the event, because pointer move is not going to be sent from that element anymore. So we need to lock the pointer ID here, and there is a pointer event lock ID somewhere. I know if you know this trick.
Yeah,
But
I think I know that trick, but I think a part of me feels like so what is actually happening here is when you click the open, what is going on is because we set in line 39 and 34 and 40, because we are setting this top and left property, it actually just make it float around. Like it feels like those values are effectively 0 and 0, so it's like it's just going to the top
yeah,
left of the screen.
no, that's
Which
absolutely
I
fine
think
for
that's
now.
fine.
I
That's
mean,
fine
we
actually.
know
Yeah.
that's yeah. We know that this is going to happen. We can make it fancier later. My point is, when you're dragging, like, it's fine as long as my mouse cursor is inside the borders of this component. But the moment it gets out, like now, but you can't see that, but like my mouse cursor
Yeah.
is now outside the border of the panel, and it no
Hmm.
longer sends that event because the pointer is not locked to this component. So
Oh,
there
I
is a
see.
way to lock it. So if you move this around, it will know that these are always coming from the original lock position. And there's a
Yeah.
way to do that. I just don't remember it.
Yeah, I think it's
We
called
can
pointer
figure it out.
capture, right?
So we can do something like pointer capture.
Set pointer capture, I think.
Thank you.
So it should be like e dot current target, referring to the current element, and then we can call a set pointer capture on that one. Yeah.
Okay, and there should be a way to release it later. Um, release
Uh,
pointer capture.
Release
Yes.
pointer capture. Yeah, I think so. I think we have to pass the ID actually. You have to pass an ID to that, which I think should be like the e dot pointer ID actually.
I'll just quick. Oh, pointer ID. Yes.
Yeah.
So
Put your pointer ID from the event. Yeah.
it can connect these two together. Yeah. See? Wow. Much more fluid. Yes, because the platform understands that these two are connected to each other. There we go. It's fluid enough. Amazing. Yeah. So we also need to handle the scenario of pointer leave and pointer up. So we know that we're coming out of the dragging. So on pointer up, we want to release the capture. Could you quickly look up if this is the correct way of doing it?
Yeah, that's correct.
Thank you. Okay. Pointer up. And we want to do the same thing for on pointer cancel. Don't ask me what's the difference. Pointer release or pointer leave.
Final leave, yeah. Correct.
Yes, and then let's send pointer cancel, pointer leave. I think those are all lowercase.
Yeah.
Yeah, so let's leave. Oh, we're not saving. So we need the saving part where we persist the position. So there's a pointer move and dragging. We still get the pointer move and update the diff. And the moment we come out of this scenario, we need to. I think we forgot to do that in the state machine.
No, I think we're actually resetting the diff back to 0. Do we need to do that?
We need to persist the position first, and then we sort of need to do that, right?
Yeah, true.
Yes, because this positioning is always based on the diff.
Mm-hmm.
So yeah, I'm just thinking because this is yeah. So if we reset diff, all we need to do is to set original position
Original
to the
position.
last exactly. So all we need to do is to go to the state machine here, and let's see. There's pre-dragging and on pointer moves. This goes to dragging. There's pointer up, pointer cancel, and pointer move. No, not pointer move, like there's pointer cancel. We probably want the same thing for pointer leave.
Yeah.
And I'll add them to the diagram later. Like ideally, you want to use the diagram and then it will update the code. We'll see that later. We basically want the same thing here. But not only do we have to reset the diff, but before that, we also have to, actually you can do it in one go.
Yeah.
So original position will be a function of the current value in the context, but we don't actually care about the event anymore because we don't send anything on pointer up. So this is going to be context dot original position of 0 plus same thing of the diff, and we did the exact same thing for the other index as well. So we update the original position to the sum of these two, so that when we reset the diff, it stays there, and the sum will still give you the updated position.
Awesome. There you go.
Yes, it stays there, and then yeah. So we need to also handle the case that when we go back to dragging again, we probably yes. So we have the original position now at this position, and the diff at here, and the moment that we do pointer move again, the pointer down again, we're sending the panel rect, and this should give us the updated position.
Yeah, technically it should. Yeah.
Yeah, we actually didn't have to like query this from DOM here. I mean, we could just say that the original position is what's in the context.
Yeah, but it starts at 0, 0, right?
Yeah.
Or we actually have to check if there's an original position and use that one before querying.
Yeah, but like we could initialize the state machine context value of the original position based on the bound implied rect, and then always rely on the context here. So we could say like original position would be like let's just say get bound inclined rect of that, and then dot x, something like that. Like we initialize the context original position based on that, and then all the time just rely on the context values here.
Yeah, but that rect is technically speaking, the rect is not available until it's open, right? Like I mean, if you use like
you're right, you're right, yeah. But maybe we can we can add an action to the state machine, so when you enter the open state, it tries to get the position from. Yeah, but we'll clean it up next time. I mean, for now, the dragging at least works.
Yeah.
And yeah, so we only need to the last step would be to just figure out when we drag again why it's a little off. I think okay, so let's just do one thing. My hunch is this panel rect might not be giving us a correct. So when I'm here, look at the original position. The next time that I go to that I send a pointer down, the value that I get from DOM rect should be exactly the same as original position. Yeah, so that updates here. So something is off.
Oh, it's actually correct.
The X was. Yeah, this is correct.
Yeah, so I think like so what's actually going on is like what we call diff is technically in my mind it should be like a difference between two things, right? But we actually don't have any calculation or computation that diffs between the events client X and the DOM rect. I think like in my mind there's some diffing that needs to be done if it's called diff, right? But we're not doing any diff. We are literally just taking the client X and putting it in context.
You're right. So maybe we could call it something like we basically wanted to just keep track of where we are along the dragging, right? So we can rename it to anything else.
Yeah,
Temp
because
position,
yeah, if
something.
you see like let's say line 39 and 40, for example, we are adding these two values together. That's literally what leads to like this incorrect state, right? Because like if you try to interact again, let's refresh the preview on the right. One of the things that you see when you when you start to drag it, yeah, let's drag it out of the way. Yeah, you see that like that diff is sort of like increasing. Original position is 0 here. When you release that, now I see. So you can imagine that when you start to drag again, we're going to add exactly. It's pretty much like original position becomes diff, and then we're pretty much adding those two
Ah, you're
values
right.
together.
You're
Yeah,
right. You're absolutely right. Yeah. So we need to think through fixing this now.
yeah.
Do you have any suggestions? Yeah, that's correct. That's the problem. Thanks for narrowing it down. I'm just thinking, so maybe we need to tweak the context values a little bit to have a better model of how we keep
No,
things.
I think one thing we can maybe do to just like improve this is we either do like top and left should either use the original position or the diff, not the addition of those two things together.
Okay,
That's like
so
a good way
essentially
of
what we keep in
yeah
the context are just top and left property values. That's what you're
yeah
saying.
yeah
All right.
something like this. Yeah,
Okay. Um, and we
I
can
think that's
actually.
probably too much change, right? I think that'll be like quite a lot of change right now. Let's sort of go back to that one and sort of like work our way back from here.
Yeah, I'm thinking. Yeah, that's a larger factor, I suppose. Yeah. But what's a hack that we can do right now to end the session and then get back to refactoring this for the next time?
Yeah, so I think the hack we can do is
Well,
if you do
yeah,
like
we could initiate original position when you open the panel, and then instead of summing them here, just
yeah we just like use the original
yeah,
position. Yeah,
exactly.
so I think this might work at least. Yeah,
Yeah. So when we get to the open state, when we send open panel, where are we doing that? Yeah, we are sending open panel. We can get the bounding client rect and send the position, so state machine can save them there.
yeah,
Yeah, that's basically what we need to do. And instead of doing pointer down, we don't have to send them in pointer down anymore, right? Because at the moment of pointer down, these are already in the original position and context.
yeah. We could just use pointer down to transition the states, and that's all. We don't have to send
Exactly.
x and y. Yeah,
Exactly. That's absolutely correct. And I'll
that
remove
might mess
those.
with the machine though, because it's
I
gonna
mean,
like
I'll change the machine
yeah,
to yeah to adapt to the changes. So this would be panel rect.x and send panel rect.y. That's great. And then open panel. So we goes there, and then we want to add another assignment action here that tweaks original position to what we receive from the event.
yeah. Context and event.
Yeah. So event.x and event.y. And what we used to get from
Pointer down.
pointer down is it took us to pre-dragging, and then we were assigning this here. We no longer need that because we already did that when the panel opens. I think this should work now. All right. Yeah, because we're updating the diff in pointer move, we actually need to update the original position now.
Yeah.
Yes. So on pointer move, we are updating the diff, whereas here we just have the original position, and then yeah. So this original position, like very bad naming because of our initial way of modeling. This is essentially the keeps track of the x and y of the top left point of the
Yeah.
panel. Yeah. So something is
No, it's
off
not there.
because
Something's off. Yeah. So let me.
yeah.
I think I know. I think I know how we can get out of this.
It's because of this. Let me just see if I can quickly
Oh yeah,
as
yeah, yeah.
pre-read.
Yeah.
Yeah. there is oh yeah, I'm dragging because we're updating uh, on pointer move. We're updating diff. But to
Here's your, okay, okay.
yeah, this should be original position. Oh my god.
Original.
Okay.
Yeah, no worries.
Yes, amazing, and it's there.
Ooh,
And then we do this, and it carries on.
ooh,
Perfection.
awesome.
Amazing. Yeah. It's 22:22 in my time zone right now, so that's the perfect time
Oh,
to
that's
end
pretty
this
late
session.
for sure.
Yeah, we're at a good
Yeah,
stepping point
awesome.
right now. This is a good checkpoint. We modeled the dragging, we connected that, wired that to the DOM using React and XState, and we're going to clean up this code, probably explain the cleanup a little in the beginning of next session, and continue adding more features to the
Yeah.
draggable slash resizable panel.
Amazing, amazing. Thank you so much, Farzad. I think this was really, really nice to see the component go from state machine to actual working code. And I think that, like, of course, when you try to sort of translate that to an actual code, then you have to do some debugging and get it working and fix the logic. And that's exactly what happened today. So, technically speaking, we're doing this in live stream, so people can actually see what the debugging looks like. It's a messy
Yeah,
process. I'm
exactly.
sure everyone knows that, but it's like really nice to see like we getting out of that and actually fixing that live on stream. So
Yeah, you see like
amazing.
how like the way that I see it is how simple it is to know where exactly things are happening and where exactly you need to have updates. Um,
Mm,
that's it's sort of like everything is clear and you know where on the street on the map you are right now. Whereas if you had modeled this with user state and a bunch of other state objects, then it was hard to understand where in the flow you are because all you have access to in that case is just the data and you don't know
yeah,
where exactly you are. So I think that's
correct.
one of the big upsides of the state machine.
Yeah, this is so awesome. Thank you so much. Because I think I mean, I definitely took a lot from this. At least just learning through, like, just like getting through the machine and like translating that logic directly to like a UI and sort of fixing the actions and the events. It's really nice to see.
Yeah, exactly. Thank you again for having me, Sage, and I hope that everybody who's watching us enjoyed this live stream. We're going to get back to another episode later and continue with building features to the same component.
Awesome. Thanks everyone. Thanks for joining. See you all in the next episode.
See ya.